this bootcamp was distinguished by building comparatively smaller number of models from scratch. I generally like to exercise the very basic muscles of people here. I like to rehearse what you do to start a model because I like to sort of firm up the instincts with respect to that. Oh, thanks very much. Much appreciated, Hop. So we're going to build a couple models from scratch today in the process of talking about dynamic networks and sensitivity analysis, amongst other things. Okay? Great. So we're going to do, how do we create a model in AnyLogic? Who could tell me? File, new model. Okay? And this is going to be called a, we'll make it in SIR, SIR model, SIR model scale free network. Okay. And the model time unit will be days here. Okay. Now, Kurt, did you find? Did you locate something sweet?
The only thing I can think of, other than a for loop that does it manually,
yeah,
using a Java 8 screen.
Yes. Well, that would be acceptable.
Great. Yeah, I did that.
Okay. Good.
Bring it to you.
Yeah. Yeah. Bring it up for my pondering. Okay. Okay, so ladies and gentlemen, we are going to we're going to get started here. Just so I have some particular parameter values that I know will work pretty well. I'm just going to go here and double check my. Yes, right. Good. Okay, and okay. Excellent. Okay, sure, Kurt. Do you want to put it down? Put it down here. Okay. Let's see. Oh, sweet. Okay. That's nice. Okay, thanks. That's right. Yeah, great. Okay. Yeah. Okay, so ladies and gentlemen, we're going to go here within this, and we're going to add a person. Yeah, that would be great. Thank you, Kurt.
It's right in here?
No, put it up.
A text file or something?
Yeah, go call up a separate text file. Thanks. Okay, so ladies and gentlemen, we're going to go add a person class. How do we do that? Okay, agent type, right, person. We're going to lend this person a very simple geometric representation for this purpose. We're going to go to the palette, and we will go down to the presentation of the palette, and we will place a circle there, and we will set the circle to be of radius 10. Okay. So radius 10, how did I do that? I dragged in a circle, I went to position and size, I set it to radius 10. Sweet. Sorry? The screen is,
Off on the right.
Oh, okay, thank you. Much appreciated. So, wrong command, sorry. Okay. Okay, come on, the light. Okay, here. Yeah. Okay, there we go. Is that better? Yeah. Okay. Okay, ladies and gentlemen, I'd like you now to go take these people and create a population of people. How do we do that? Where does the population live? Main. So we drag in person to main, and we're going to call it population. But we want to be able to vary the population by experiment. How do we do that? Yeah, we enter a parameter called population size. that lives in Maine as well, population size. And what sort of parameter is that? What's its type? Integer, and leave it a default value of 100. Now, does just the presence of that parameter mean that population is definitely a population? No, and in fact, the absence of little brackets after that indicates it's just a single person right now. What do we have to do to make it a population? Make a population of agents. And what's the initial number of agents? This dot population size. Okay. Okay, ladies and gentlemen, I'd like you to build the model. Build it here. Okay. Great. Next, ladies and gentlemen, I would like you to go and I would like to now just, if we run this model, what will we see? Anyone? Will we see a population? Yeah, the circles are all atop of each other. Okay? So you could do it. Where are they? They're all up here. They're all sitting atop each other. Okay, ladies and gentlemen, let's go now and we're going to place those people at locations randomly distributed around the space. How can I do that in a way that even people coming into this population will be distributed evenly in space? How would I do that? Anyone? Where do I specify people's location? Indeed, yeah. Okay. Okay. So let's go to the population. Go to initial location, and I'm going to set it so that we are going to have a situation which is robust, even as we enlarge the space and so on. So how would I do that? In the specified point, and what would I put here so that even if I change the width of the space, even if I adjust it, it will still work? Uniform between 0.0 and what? This dot space width. So this is going to determine whatever space width applies now. It's going to draw this within that range, and the same thing for y. But except we're going to say this dot space what? Okay, this dot space height. So first it's going to determine the space height, and then it's going to draw a random number, uniformly distributed continuous random number between 0 and whatever that is. We okay with that? Let's run this model. Make sure we've got people located. Okay. Great. Great. Are people located all around? Okay. Excellent. Okay. Next, I'd like to go and I'd like to place this population into a network that initially is going to be a distance-based network. How do I do that? Where do I go in AnyLogic for that? You go to main, ladies and gentlemen, because that's what contains the population. It's a bit counterintuitive. You go to main, and you're going to go to the network type here and set it initially to be distance-based. And I'd like you to set the connection range to be 100. Okay? How did I do that? The population that we want to, who we want to arrange, that lives in main. So we went to main, we scrolled down to space and networks, and we set the network type to be distance-based with connection range 100. Is that okay? Are we okay with that? Okay, ladies and gentlemen.
So if you had more than one population in main,
yes.
you'd have to
Good question. Excellent question. I actually think this was a downgrade of AnyLogic from 6 to 7. We used to have an explicit environment object that you could associate with a particular population. So one population would have one network, one could have another type. But unfortunately, from my perspective, AnyLogic sought to simplify the situation, which is an admirable impulse. I just think in this case, it clipped a little bit too much functionality. And so if you have more than one population and you want multiple network types to apply to those different populations, there's ways to do it, but the basic gist of it is that you can, if you just want to exempt one of them from the network, you could simply unselect one of them, them here, just leave one selected, the one that you want to be, whose properties you want to be set by this. You could just leave that one selected and unselect the others. If you want to have them laid out simultaneously with different networks, you can do so with user-defined networks, certainly, where you construct the network. There may be a clever way to do it with kind of embedded agents within that, but basically it's not nearly as nice as one would like. Okay. Okay, so let's run this model. This to show sensitivity analysis, but I'm also going to use it to show a little bit about some additional statistics, since that was a big interest, input, output yesterday. Okay, so where's the network? Do you think there is a network? Yeah, so how do we make the network appear? There is a network. To show that there's a network, ladies and gentlemen, how could we visually show that there's a network? Well, we could make each person's circle be proportional in size to, or roughly proportionate to, the number of connections that they have. Okay? How would we do that? Let's suppose we wanted a person with a large number of connections to be larger physically in their circle. Where would we go? Go to the circle, and what we would do is go where on the circle? Yeah, we could go to the radius of this circle here, ladies and gentlemen. We could set it to be a dynamic value, and I'm going to have it be 5.0 plus 2.0 times this. Who's this referring to? The person, because this is all being done in person. This dot get, flipping, okay, I don't know what's going on here. This dot get connections number. These things I put in, like get connections number, get connected agent, things like that, connect to, that we'll be seeing today. These things are in that little sheet of that sort of little hints of sort of common AnyLogic functions. So you may find that handy. So the radius I've set, remember I had to click this little thing. And then I set to 5.0 plus 2.0 times this dot get connections number. This is going to return the number of people to whom I'm connected in the network. Okay? Oops, there we go. Okay, so let's run this thing now. Okay, what do you expect to see? There we are, circles of different size. So that's a clear indication, ladies and gentlemen, that a network is there. It's just we don't see it. Why not? Why don't we see it? We haven't drawn the line. Where do we have to go to draw the line? So where is it? Connections. Is it this connections? Connections in person. Don't get those confused. By the same token, folks, you want to adjust circle size, don't think, oh, there's a circle, all of its size. No, you don't want to do that. You want the circle person. This is just kind of a depiction of that there's a population of people there. This circle is the one whose properties we want to set, the radius. And And these connections within person, those are the ones that we want to FRUB, not to get the line drawing, not those in main. And we're going to draw the line connecting agents. Okay? Are we okay with that? Let's run this. We ready? Ready or not? Maybe you want to take a little bit more time. In-person connection, scroll down to the animation. You may have to expand it. And then you'll tick this draw line connecting agents. Are we okay with that? Okay, let's run it. And now we shall see before us a tapestry of interconnected agents. There we are. You see them? And you can see the number of connections is associated with the size. Larger, more connections. So sometimes you can use visual cues to help you debug a model, what's going on. You saw me print out things, but another way you can do that is by doing things like setting the size and saying, you know, I have a hypothesis that maybe there's a network but it's just not being shown. How could I make that visible? Well, you could make the size of the person be dependent on the number of network connections, and that would show it. And then it would let you say, okay, how do I make it visible? So it's not a matter of whether or not it exists, it's a matter of whether it's visible. So you can use visual cues to help you debug a model. Okay, ladies and gentlemen, great. Excellent. Who needs TA help? Okay, great. Okay, now we're going to do something we've never done before. Okay? But it's related to the input-output thing in which you expressed such fervent interest yesterday. Okay, ladies and gentlemen, I would like to go to main, go down main, and I would like to go add into main from the palette. I'd like to go add in something from the analysis palette. Okay? And this item that I'd like to add in is going to be a histogram, ladies and gentlemen. A histogram. It's going to be a histogram object, not a histogram 2D. We'll see those in the fullness of time. But a histogram, ladies and gentlemen. Now, ladies and gentlemen, sometimes good things come in pairs. And I'd like to, and this, so it will be with histograms. We're going to have a histogram, then we're going to have a histogram data set that's going to provide us the requisite information. So ladies and gentlemen, the histogram's name is going to be connections. It's going to be called degree histogram. Degree histogram. Can anyone tell me, when I say degree of a person in a network, to what does that refer? If I say someone's degree is 2, what does that mean? Yeah, number of connections that they have. Ladies and gentlemen, agent-based modeling and social network analysis are not quite fused at the hip, but they work very naturally together. And indeed, we can get much insight from the social network side by using agent-based models, and I would add vice versa. And we can incorporate into agent-based models results of social network analysis. And indeed, one of the models I provide you provides a way of importing from a very popular social network analysis package, namely PIEC, importing the files into AnyLogic. Okay? And there's been discussions with AnyLogic about having them support said functionality. So here we have a histogram. It's going to be called degree histogram. Okay? Next, we're going to drag in a histogram data object that's going to be called degree histogram data. Now this is going to hold the data that is going to be visually shown in the histogram. And you notice that this is where you get down to business, like the number of intervals in the histogram, whether to calculate the cumulative distribution function, whether to calculate percentiles, so sort of quantiles, for example, and it also will provide a value. For now, we're going to leave value blank. You notice you could say, are the sort of interval sizes fixed? And ladies and gentlemen, for the histogram, we are going to here have it set in the data update, do not update data automatically. Are we okay with that? Do not update data automatically? Are we okay? Okay? Okay. We're gonna be doing it manually, okay? Next, ladies and gentlemen, sometimes you have it updating automatically, but often you don't. Often you have it updating data in a way that requires a little bit of code to insert the data. Okay?
Could you please repeat this last?
Sure. So I added two things. I added a histogram, and I called it degree histogram, and then I added a degree histogram data object as a histogram data object. Okay? Now, I went and the only thing I changed in the histogram data was I went down to data update and said, do not update data automatically. Okay? Are we okay with that? Ladies and gentlemen. Ladies and gentlemen. Next, we're going to do a key thing. And this always happens. This is a repeated thing. When you're using histograms, you have a histogram data object. You need to go to the histogram and you need to say add histogram data. And you're going to say, you could say number of connections, to use a more colloquial term. And this is the confusing thing about histograms. This reference to histogram here is actually a reference to histogram data. Okay? It's a reference to histogram data. So for histogram, we actually say this dot degree histogram data. Are we okay with that? So we're going to ask this histogram to depend for its data on this thing. Now we're just about done with this. And this histogram will provide us with insight of considerable interest. Notice with the degree histogram, it gives us some options. We can show the cumulative distribution function. We can also show the mean. We can ask it to show the mean. Regrettably, showing the median is not currently exposed as a value, despite injunctions from North America. Okay, ladies and gentlemen, there's one final piece to the puzzle, one final win for the Gipper, okay? And that is the event. We're going to have it be update degree histogram. There's going to be an event called update degree histogram. This is a reporting event. And indeed, ladies and gentlemen, it's going to go off once per week. So how would I set this to go off once per week? As I might often do, in terms of periodic reporting for a kind of reporting process, an observer process, a process that's reporting on model. What would I do? What sort of trigger type would it be? It would be timeout, but its mode would be what? Cyclic or cyclic, yeah. Okay? And recurrence time will be what? 1 week. Great. Just about done, ladies and gentlemen. But there's one ugly fact that has to be put into here. Okay? Now, this could be done in a couple of ways. I'm going to do it this way. Ladies and gentlemen, the first thing we're going to do is we're going to clear out the existing histogram. So the way you do this is you say this dot degree histogram data. We want to get rid of everything that's in there now. Dot, and you notice if you press Control Space, you can have an option. It'll be called reset. Okay? reset. And it describes what it does. You notice here we have a large number of different items we can get from it. We could query this to get, for example, PDF entries in the PDF, or the it's actually the empirical distribution, or this percent high and low. Sort of, you can get a variety of different pieces of data out of this histogram, which are of interest. Okay. Oh yeah, yeah. The median has been added to some things, but not to all. It's unfortunately something that is very has limited support. Okay, so ladies and gentlemen, in addition to browsing this, we're just going to reset it here, and that's because we want to clear the decks. We're going to display the degree histogram as it stands now. Now this is going to be initially static, but later this morning we're going to be adding network dynamics in, okay? And then it will be, it may be adjusting. Okay, and now we're going to go for each person, we're going to call them lowercase person, in this dot population, we're going to add their number of neighbors to this histogram. This dot degree histogram data dot add. So this is going to add a data item to the data being summarized in the histogram, and it's going to be person. So we're going through each person in the population in turn, calling them person. Okay. What is this person? That's just saying, oh, that this thing is it's drawn from the set of all possible people. It's this is kind of our class person. It denotes personhood. This is each person in the population who is a person. It's a reference to an instance of person, technically. We're going to be adding their get connections number. I just showed that to you a few minutes ago. Where do we see get connections number before? I'll put this up on the big screen. Where do we see get connections number? Yeah, for the scale of it. Remember that, the radius? I introduced that to you. And now we're going to be adding it in. I'm weaving these together to teach some lessons, okay? And sometimes I have multiple goals in putting in particular elements. Okay, there we go. Persons.get connections number. So what are we doing? We are populating the histogram with information about each person's number of connections. And that's what it's going to summarize across the entire population. Does that make sense?
The reset do again? I missed that.
Sorry?
The reset.
That clears it, so it clears the deck. We're going to be summarizing it. Currently, it's going to be static, and we're just going to be repopulated with the same data. Later, we're going to have a dynamic network, and so it may change, in which case we're interested in seeing it, okay? The results of the change. Are we ready? Okay. Ladies and gentlemen, let's run this thing. Let's build it first, and let's run it. Okay? So here, oh, it's already running it. There we go. And where's the histogram? I put it up there. Do you see it there? Ladies and gentlemen? Now notice that if you go click on degree histogram data, you can get the mean here, the min, the max, standard deviation, etc. Out of this. Do you see that? Here's the CDF. This is a cumulative distribution function, and this is the degree distribution. So what is this telling us about the degree distribution? Well, it varies pretty widely, doesn't it? There are some people who have upwards of 20. Some people who have 0 connections, in fact. the most common values are somewhere around 10. Okay? We okay with that? Ladies and gentlemen, that's good. Next, I'm going to put in place for the person, I'm going to put in place a bit of infection machinery so we can remind about sending messages, okay? Ladies and gentlemen, I would like to go to add in a state chart, okay? How do I add in a state chart? How do I start adding it? Entry point. And this is going to be called infection state chart. Okay? We're going to have a susceptible. We're going to have an infective and infected as well. And we're going to have a recovered. And then we're going to have, ladies and gentlemen, then we're going to have connections between them, okay? So we're going to have a connection from susceptible to infective, and we're going to assume that each contact between an infective and a susceptible transmits infection. Another one from infective to recovered, and actually another one from recovered back to susceptible. Okay? Here we go. And then we want to bend that round so it's prettified a bit. Okay, ladies and gentlemen. So now we're going to set the recovery time here to recover going into this state here going into recovered to be a rate of 0.1 per day. Okay. And this will be called recovery, and I'm going to show the name. Okay. For the waning of immunity, we're going to have a timeout transition of 50 days. 50 days. And for susceptible to infectious, what sort of, by the way, I'll name this one waning of immunity. We'll show the name. And for susceptible to infective, what sort of transition do you think that will be? It'll be called infection. What sort of triggering type? It'll be a message, exactly. It's going to be contingent on a message being received. I'm simplifying some things so we can get through this because a lot of the goal is to teach a few things. It's less central in this. You notice I'm playing fast and loose with not specifying parameters for these things. I actually feel somewhat guilty about showing you bad habits here, but you know, we could create parameters in main, and currently I'm experiencing an internal civil war about whether to do that because part of me revolts so strongly against fixed numbers there. In fact, okay, so that side is victorious. Okay, so let's go to main. So if we wanted things like the duration of immunity, the time to recovery, if we wanted that to be specified on a per scenario basis, how would we do that? We want it to be specified per scenario basis. Where do the parameters need to live? In main. So let's go down main, and we're going to add a few parameters here. Okay. Okay. So we're going to add a parameter that's going to be called mean duration of mean infectious duration. It could have alternatively called mean time to recovery, mean recovery time, and that's going to be, ladies and gentlemen, 10.0, and we're going to have another one which is going to be mean duration of immunity, and that's going to be time 50. And then we're going to have a contact rate, which is going to be contacts, we call contacts per day, and that will be 10. And really, I should have said mean duration of immunity in days, mean duration infectious duration in days, if I had wanted to be more careful about it. So contacts per day is 10. Duration of immunity is mean duration of immunity is 50. For good measure, I'll put 0.0. Mean duration is 10 in days. Now, I should have been more careful because I'm specifying those as doubles. What could we do to improve the transparency? Well, instead of making it type double, we could make it type time, and we could specify days. Then it actually documents itself. This is 10 days, ladies and gentlemen. Mean duration of immunity, we could keep it as a double. There's no big harm in that, but here it's more self-documenting. Time, days. Contacts per day, I'm going to make this a what? Is that a time? It's a rate. And what's the rate going to be? Per day. And then I don't even need to say contacts per day. I could just say contact rate. Okay? So sometimes making it self-documenting is kind of nice there. Okay? Okay, so do the Statechart. Now, the recovery time, the recovery rate is going to be given by 1.0 divided by the main recovery time. Okay, mean infectious duration. Why is that? Because if you have a rate transition, it turns out that the rate is 1 over the average time, and the average time is 1 over the rate. They're reciprocals of each other. It's the nature of exponentially distributed residence time, that they're 1 over each other. It's a fact of statistics. Okay. Ladies and gentlemen, for the duration of immunity, it's going to be timeout is going to be mean duration of immunity. And notice it's days. In both cases, I'm checking the units per day, making sure they line up, and days. Okay? Great. We're just about done. Just about done with this core logic of this. Next, we're going to add in to the palette a transition from infective to itself. And what's the purpose of that transition going to be? It's going to represent what? Contact. What sort of triggering is it going to be? Rate. And what is the rate going to be? It's a per day rate. What is it going to be? Exactly. Main dot contact rate, contacts per day. Okay, great. What's going to happen here?
Send a message.
We're going to send a message. We're going to send a message. Okay. So we could go and send a message here. Now, if we had multiple messages, we'd best do it in an option list, and I'm still going to hew to that. So how do we add an option list? Does anyone remember? We can add it to the model as a whole, new option list. And this is going to be called messages, and it's going to have a single element, which will be called exposed. Remember, options list, we used them for our very first model to denote sex too. Options lists are extremely helpful to denote categories and to note it in a way that you won't mistype it. It'll be checking. Okay? So it's called exposed and it's in messages. How did I do that? I right-clicked on the model as a whole and said new options list and said exposed. Are we okay with that? Having done that, what are we going to do? Having put in an options list for exposed, what are we going to do here? Yeah. We're going to say this dot send, and actually we don't just want to send, we're going to send to random connected the message exposed. Now we could messages dot exposed if we want to be quite specific, but it's going to be exposed, okay? Great. Great. Okay. Now ladies and gentlemen, now we want to, let's run this model and we'll draw a lesson from it. So we're going to run, and ladies and gentlemen, we are going to go and run in this, so I just built it. Let's run in the simulation, and we're going to run it, and do you think anyone's infected? Here's a susceptible person. Here's another. Here's another. Why are they all susceptible? Why are they susceptible?
You have to put an action when they receive.
Exactly. Exactly. Well, we have this action. It's unconditional. They will transition. So if they receive something, they will get it. Then why isn't the population burgeoning with infectious people? Nobody got infected at the start. There's no one at the start to get infected. So how are we going to do that? Well, there's a couple of ways, ladies and gentlemen. I'll show you. I showed you earlier a way. Does anyone remember when we had that model earlier? We had one way to start a fraction of the people infective. How did we do that? We had a branch coming in, and that's perfectly legitimate. But let me show you another way. These are common things, so it's good to see a couple ways. I could set it so when I click on it, it gets infected. How would I do that? If I want to set it so when I click on it, it gets infected, how would I do it? Sorry? On click, indeed. We could do it in on click. I'm going to show you a different way that's very common in our work. So here we're going to go to main and we're going to add an event. And this is going to be called initial infection event. Okay? Okay? Initial infection event. It's going to occur once at time 0. And what it's going to do, it's going to be explicit. I like to make these things explicit. There's other places we could put this where it will be hidden. But I'm going to put it here, and I'm going to say this dot send, actually it's deliver to random agent. Sorry, it's not send to. This dot deliver to a random agent inside, and I'm going to deliver the message exposed. In other words, I am going to deliver it as main to one of the people in main. Okay? Are we okay with that? Okay, Now, if we run it, will we see a nice blinking population? What's still missing?
We didn't make the fill color.
We didn't make color. Yeah, let's go make color so we can at least see the progress here, okay? So, initial infection event just infects someone at the start. Are we okay with that? Okay, now, how are we going to make it a different color for each of these? I'm rehearsing the basics. Create a variable, and the variable is going to be called okay.
Color for you.
Okay, thank you. Okay, color with you. Okay, and it's going to be of type what? Other color with a capital C. This is kind of a balance. The U.S. style wins for the name of the class, but for the variable we use the U. But you may use secretly something else. None of the TAs are going to police that. Okay, so it's going to be a variable of, I call it color with U, and it's type color, capital C. Are we okay? Okay. For susceptible, set it to lime. This dot color, and that's, yes. Oh yeah, should we set an initial value? Thank you. Very good point. What should the initial value be? Black. Let's make it black. So it's in a different color. It'll be obvious if we forgot to set it somewhere. The entry action for infective, we'll set it to red, and for recovered, we'll set it to gray. Okay, gray. 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 Okay? And just for good measure, let's color each one correspondingly. So I'm gonna choose this one to be like that. And again, it's not enforced, but it's kind of a nice thing. It will connote to us what these colors mean when someone sees it. Here's gray. This is silver. That's gray. Boom. There we go. Okay, and if we run it now, will we see nice colors? Have we finished the logical chunk of work involving color? What do we still have to do? Yeah, we have to set the color of the circle according to that. We set up a thing called color, and we've certainly assigned it, so the intention is there, but we haven't finished it through to its logical conclusion. This variable color is disconnected from whatever color is here. It's not paying attention to the color at all. So how are we going to pay attention to the color here? Set the appearance, ladies and gentlemen, so that the fill color is what? Is color. This dot color. To be kind of nice. Are we with that? Okay, let's run it. Let's run it. What do you think you'll see? What do you think you'll see? Okay. Okay. So here we see it going in. We could run it full tilt with this. It turns all susceptible. Why is that? Why is it goes through kind of pulsations, but then it turns entirely susceptible eventually? Well, ladies and gentlemen, it's through the stochastics of the situation. So here we have a situation where people are susceptible, infective, recover, and then they wane. But if they wane and they're back to susceptible, under what conditions will they still be infected again? Anyone? Under what conditions would they be infected again? Well, if they were exposed to an infective. But maybe there's no infectives anymore. Maybe all the infectives have recovered too. Maybe everyone else is recovered or susceptible. Maybe there's no infectives right now, in which case they'll never get infective again. Okay, let's let's copy that. So in other words, by the time people lose immunity, and maybe they're not exposed to infection anymore. Let's copy that, and then let's put in a new one, paste, where we have. Well, we're gonna experiment with two different things. We're gonna have short immunity duration, or brief immunity. That's a better way. Brief immunity. Probably we should say immunity duration such and such. Okay. And I'd like to set the duration of immunity to be 25 here. Okay? Okay. Could you work with Kurt, who knows the restaurants here really well? Could you work with him? Try to okay, thanks. Okay, now let's run it. What do you think the effect will now be of briefer immunity? Let's think this through. How do you think immunity that it affect things? Sorry? Yeah, so the people who recover are more likely to get exposed to an infected people. There's more likely to be someone around who's still infective after they lose their immunity, right? Does that make sense? Let's think this through mechanistically, right? Okay, so we have someone, they're infective right now. They recover. And suppose it takes a very long time for them to lose immunity. Well, there might be after that length of time, there might be no others who are still infected. But if they lose immunity quickly, there's likely to be others around who are still infected. After all, they got infected from somebody, originally. So there's likely to be someone around who's still infective. So here we see this kind of situation where it persists. Let's try another one. So let's go call the simulation baseline, okay? Baseline. That's our baseline. Copy baseline again, and let's go this time I call it baselines. We should call it baseline. Okay? And now let's copy that, and now let's put in place, ladies and gentlemen, paste here. We're going to put in place one that's called long infectious period. Okay? And we're going to set now the infectious duration to be 20 days. What do you think the effect of that is going to be? Remember, in the baseline, if we ran it, infection reliably dies out at a period of time. Right? True or not? True or not? It's going to run it, and then it turns all green. If immunity persisted, how about long infectious period? Notice it highlights it in bold to 20 years. So, ladies and gentlemen, what do you think the situation is going to be for that? Sorry? Good. Okay, is it going to stay persistent?
Should we ask people to order pizza or subs or something? Should we ask people to
Why I'd like that idea. Yeah.
Should we do that right now?
Sure. Yep.
So just a little pause. We're going to order some lunch. And so we were thinking either subs or pizza. And I'm wondering if anyone here has any particular dietary questions or just preferences about what they would or wouldn't like for that.
Vegetarian.
Yeah, vegetarian.
Vegetarian? Gluten-free? There's gluten-free options for those things, yeah. So we have one gluten-free, a couple of, does anyone want to eat vegetarian just because they feel like it?
Vegetarian.
3, okay. And is everyone okay with pizza? We'll get vegetarian, gluten-free options, then kind of a variety of different meat things. Is that satisfactory? Great. Then I'll just count.
Yeah, and if anyone would really like to make sure that there's something responsive to your needs, you're welcome to go out with Kurt and
Sure.
confer, and you could look at the particular menu involved. And
Great,
yeah. Okay.
great.
Great. Thank you, Kurt, and thank you, Aiden, for taking care of this in light of Rifat's illness. Okay, ladies and gentlemen. So here we have a situation. We're going to put in place, given the interest in model input-output, we're going to capture another sort of data here. Remember yesterday we captured incidence counts, weekly incidents? You know, I'm wondering right now, maybe we could, given people seem to be interested in specifying pizza, let's take a 5-minute break, okay? So it's a good time for a health break anyway. And we'll come back to this and we'll add features of this model. The most important thing we're working to at the moment is parameter variation, understanding the impacts of stochastics, okay? So 5-minute break, you can confer with Kurt and Aiden concerning the details of the availability, craft a solution of interest to you, and we'll be back in five minutes to take this model in some new directions with a couple exciting additions and sensitivity analysis.